Alright folks, welcome back. In this video we're going to discuss another example of inequalities. Remember, this is kind of like the opposite of equalities. Not really the opposite, so to speak, but we're just broadening our spectrum of values that are acceptable for our values. For our values of variables. Let's take a look at this example here. 3x is less than or equal to 12. Now here, if it were just an equality, we would say, alright, divide both sides by 3, and we would see that x is equal to 4, because 3 times 4 makes 12. But here we want numbers that are less than or equal to 12. So 4 is an option, because 3 times 4 makes 12. That's fine. But 3 is an option as well, because 3 times 3 is 9, which is less than 12. So is 2, so is 1, so is anything less than 4. Okay? So how do we get that? How do we solve inequalities? How do we find that range of x values that satisfy this inequality? We do it just like we would a normal equation. We would solve by dividing both sides by 3. We divide both sides by 3, and we get that x is less than or equal to 4. So this means that 4 is an option because it has a less than or equal to. 3 is an option. 2 is an option. 1 is an option. 0, all the negatives, and all the numbers in between, all the fractional values, all the decimal values in between each of those whole numbers are options as well. So when we're solving inequalities with multiplication and division, it works the same way, except for one notable scenario. Okay, this is the one exception I mentioned in the other video. Let's say I had negative 3x is less than or equal to 12. I had said to this point it's the same as solving normally, so I would maybe divide both sides by negative 3, and I would get that x is less than or equal to 4. Negative 4, excuse me. Now, here, this is wrong. This is wrong. This is wrong. Why is this wrong? Take a look. Let's plug in negative 4. So I have negative 3 times, let's pick a number that's less than negative 4, meaning more negative. So let's say negative 5, right? Negative 5 is certainly less than negative 4. Well, that's equal to 15. Negative 3 times negative 5 is a positive 15, but hold on. It had to be less than 12. Is 15 less than or equal to 12? It is absolutely not. So what happened here? Why is it that now I'm getting something that's wrong, where before it worked out so nicely? The thing is, when we divide or multiply by a negative, we need to flip the inequality. So, instead, what we have is the following. Let's get rid of this. This is all wrong. This is no good. If I have negative 3x is less than or equal to 12, I do divide both sides by negative 3, and I do get x by itself, and I do get a negative 4 on the other side, but instead of it being less than or equal to, it's going to be greater than or equal to. So anything bigger than or equal to negative 4 is an option. So negative 4, negative 3, negative 2, negative 1, 0, all the positive numbers and all the numbers in between. If we plug in and we check, let's say we plug in negative 3. We would have negative 3 times negative 3, which is equal to positive 9, and sure enough, that is less than or equal to 12. So when we have these inequalities and we're multiplying or dividing by a negative number, we need to flip the inequality when we are solving. That's the one catch. That's the one thing to look out for. All right, so check back in for more examples to see how we incorporate this into larger problems. I'll see you next time.